We're going to talk about something called the discriminant. So if we look at the formula, the quadratic formula, x is minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. This thing over here, this part over here, this is what we're going to call the discriminant. I'm not sure why I just rewrote the word, given that I have it in big up there, but this part over here, so the b squared minus the 4ac, the part under the root, is the discriminant. And what the discriminant does is it's going to give us some information about the quadratic. So, for example, let's say I said, so let's say example 1, f of x equals 2x squared minus 20x plus 49. And I want to find the zeros. So I want to find the zeros. So find the x-intercepts. So how do I find the x-intercepts? What I'm going to do is I'm going to have the quadratic formula. So the quadratic formula is going to be x equals minus 20, so 20 plus or minus the square root of b squared, which is going to be 400 minus 4 times 2 times 49 over 2 times 2, which is the square root of, what is 8 times 49? 8 times 49 is 392. 400 minus 3, oh, that was a mess. I apologize for that. That should be a 2 times 2. It does become 4. So x is 20 plus or minus root 8 over 4. Which is 20 plus or minus 2 root 2 over 4. I'm kind of zipping through this, I recognize that, but that's okay. Which is, take a 2 out of everything, which is going to be 10 plus or minus root 2 over 2. And the key part is that there's 2 solutions there. Okay. And let's say, we're going to have to come back to that. Let's say instead we do the same thing for, what color did that in? F of x equals 2x squared minus 20x plus 50. So then x is going to be minus this is plus or minus the square root of 400 minus 4 times 2 times 50 over 2 times 2, which is 20 plus or minus the square root of 400 minus 400 over 4, which is 20 plus or minus the square root of 0 over 4. And the square root of 0 is just 0, so it's 20 plus or minus 0. And adding or subtracting 0 doesn't make a difference, so x is just 20 over 4, which is just 5. Okay. One more. F of x equals 2x squared minus 20x plus 51. We want to find the 0, so we're going to make this equal to 0. I've kind of been skipping that step. I shouldn't, but when we find to find the zeros, we have to make the y equal to 0. We have to make f of x equal to 0. And we need that 0 to be able to do the quadratic formula. Let's pretend I did it for the other 2 examples. So we're going to have minus this, 20, plus or minus the square root of 20 squared minus 4 times 2 times 51 over, I think that's 408. 4 times 2 times 51. Yep. So x is going to be 20 plus or minus the square root of 400 minus 408 over 4. So x is going to be equal to 20 plus or minus the square root of negative 8 over 4. And the square root of negative 8, is, it's saying math error because you can't take the square root of a negative number. There's no two numbers multiplied by each other that would give you a negative. If it was negative, a negative times a negative is a positive times a positive is a positive. It simply doesn't work. So in this case, there are no solutions. So we're going to summarize this thing. And we're going to summarize it looking at the discriminant. So what we had when the discriminant was, what was the discriminant for that original one? So the discriminant was 8. We had two solutions. We had two roots. And when we were taking the square root of 0, we had one root. That's when we only had one solution. We just had the 5. And when we were taking the square root of negative 8, we had no roots. We had no solutions. So in other words, when the thing under the square root is positive, it's two roots. When it's 0, it's one root. When it's not less than 8, there are no solutions. So writing it in a different way, if b squared minus 4ac is bigger than 0, then so we can have b squared minus 4ac is equal to 0, and we can have b squared minus 4ac is less than 0. If it's bigger than 0, then that means we are going to have two distinct real roots, which means that they're real, so they're actual numbers, and they're distinct means they're two different. Here we have only one distinct real root. So there's kind of two roots, but they're both the same number. So only one of them, there's only one distinct one. There's only one different one. And for this one over here, there are no real roots. Though, you don't really have to know this, but there are something called imaginary roots. Imaginary roots. And if you feel like looking it up, you could just look up that some other time. So based on the discriminant, if it's bigger than 0, equal to 0, less than 0, it tells us how many solutions there are to the quadratic equation.